Okay. Good morning and welcome to all of the pre-calculus 40S students, and thank you for joining us today. So a couple of things that I would like to accomplish today is first, I would like to go over some of those questions that were assigned yesterday. I'll go over some, and then at the end or the second part of that, we will talk about the new topic for today, and then that's basically the plan. So what we're gonna do is I just want to kind of review what we talked about yesterday, and then move on to that one. So yesterday in lesson number 2, we looked at the transformation y equals to a sine of b times x minus c plus d. Now, this has gotten so familiar to us because we've done so much in this particular topic. So, in this case, the parameters A, B, C, and D mean something in our situation. So, and it also works for the same way in this in a cosine. So I know I wrote down sine there, but it also worked for the function cosine. So just to kind of take a look at this one in here, A talks about the amplitude of the wave of the graph. So when we look at the transformation point of view, amplitude is a vertical stretch, and then if A or compression, as well as the A will tell us if it's reflection, also reflection into the x-axis. Okay, so that's what the A will represent. Now the B, in terms of our sinusoidal function, the B will actually help us determine the period. So this will help us determine the period. Okay, so we said period is equals to 2 pi over b. That's the concept that's related to the graph. But if we were to connect that into our basic transformation, this actually, the B tells us, not use, tells us the horizontal stretch or compression, also reflection, horizontal into the y-axis. Okay, so we're looking at the B in terms of the sinusoidal function. So the B tells us the period. Okay, so how long will it take to make a complete cycle? Now C is, we call it a phase shift. Okay, so basically moving it to the left or to the right in a transformation context. That's a translating horizontal translation, either to the left or to the right. Okay. And then the D, I'm looking at the notes that I looked at, the notes that we took yesterday. We talked about the D, and then the D basically is the vertical translation, moving the graph up or down. But the I don't think this is something in the booklet. The D actually tells us where the median line is, middle or median line is. Okay, so we will talk about that today. We will figure out, well, where is the middle line in the sinusoidal function, because where the middle line, it fluctuates up and down. Okay, the graph fluctuates. So in terms of the D, when we looked at the transformation, the D is a vertical translation, either up or down. Okay, so the A parameter A, B, C, and D actually talks about a lot and describe how this sinusoidal function graph would look like. So that's the kind of like a review of what we talked about yesterday. Now, just going about with this one in here. So this is one of the questions from the book on page 521. So the amplitude is the A value. So the amplitude is 5. Okay, so amplitude is 5. That's that one. Here, amplitude for y equals to 2 cos of x. Again, this A is our amplitude. So A is equals to 2. Now, if A value is negative, amplitude will always be a positive. So an absolute value of A, which is our amplitude. Okay, so amplitude is always positive. Now, letter C, this is question number 3C. What is the period of y equals to 10x? So yesterday I said that 10 talks about how many complete waves will happen in 2 pi. So what's the period? So period is going to be 2 pi over 10. So 2 pi over b, I'm just going to write that down. So p is equal to 2 pi over b. And then the b value is 10. So it's going to be 2 over 10. We can reduce that, of course, and we can say it's going to be pi over 5. Okay. We're going to leave the tan of x for now. Leave that for now because we will spend, I think, one day talking about the tangent function. Okay, so leave that for now. Because tangent is actually a totally different graph altogether. So phase shift, we're looking at the phase shift, meaning horizontally translating either to the left or to the right. So phase shift of y equals to the sine of x minus pi over 7. So the phase shift is this one here, the c value. So phase shift, c is equals to pi over 7. And it's going to be plus pi over 7 because it's going to be always x minus c. And then over here, determine the phase shift. Y is equals to cos of x minus, I'm just going to write this down, and I'm pretty sure you remember this from before. The reason why this is plus is because a minus a negative value, which simplifies a positive. So that means our c value is negative pi over 12. So that tells us that the cosine function, the cosine graph, got shifted to the left, pi over 12. Okay, so I won't, yeah, I won't go over this one because I don't want to take so much time. Um, I'm going to go over question number 5. Question number 5, asking the question here, does this graph represent a periodic function? So a periodic function is a function that continuously repeating itself over and over again. Now this one here, as you can see, it repeats over again, but it's not exactly over and over. Okay, it's not exactly the same thing. So this is no, because um, the the graph does not repeat, okay, over and over again over the domain. For it to repeat, it has to be the exact same shape. Okay, so this one here went up to 8, and then went up to 9, and then it went up to no, not 9. That's, what is it going up by? 2, 4, 6, 8, 10. So it went up 2 and 11, and then went up to over there. So it does not repeat over and over again. So this is not a periodic function. Question number 6 was not assigned, so we're going to go over question number 7. So in terms of question number 7, it says here, I didn't really focus on this one yesterday. We looked at the possible transformations, but we didn't really graph yesterday. So how do we sketch this graph? I didn't teach you that yesterday. So the very first one strategy that you could do is to look at the cosine of x graph. What's a basic one? So what's a basic cosine of x graph? Let's see here if we can remember this one. So y is equals to cosine of x. Okay. Well, when we look at the cosine of x, the x is the angle, and then the cosine of x will give you the y value. Okay. So in terms of cosine, okay, so the x there is the angle. Okay, so the x is the angle of rotation. So this is the angle. So it's going to be 0, pi halves, pi, 3 pi halves, and then all the way down to 2 pi. So what we're going to do, cosine talks about the x coordinate of the point on the unit circle. So if we look at that one, okay, it's going to be x, y. So x is the angle, so 0, pi halves, pi, 3 pi halves, 2 pi. So the x is not the x coordinate, but the angle of rotation. So here, if our angle is at 0 degrees, or no, radian, 0 radian, the x, the cos of 0 is 1. Over here, the at pi over 2, the cos of pi over 2 is 0. Okay. And then at pi, it's going to be -1. 3 pi is 0. 2 pi is back at 1. Okay. So here's a thing that you could think about. This is what I think about when I talk about cosine. Cosine okay, this is my 0, this is my 2 pi. Okay, 0 to 2 pi. The cosine starts at 1 and it finishes at 1. Okay, so there shouldn't be a point there. It should be up here. So it starts with 1 and then it does the full cycle and then goes back to 1. So from there up to 2 pi, in the middle is going to be the minimum. So this is pi, minimum, and then a quarter, not a quarter, but half a pi, pi halves. So this is pi, so this is pi halves, and then this is 3 pi halves. That's where it's going to be 0. So these are the 5 key points that we talked about in lesson 1. So what does a graph look like? The graph would look like this. Okay, so that's a one complete cycle. So that's what y equals the cos of x looks like. So get really, really familiar with this one because you need to. Okay, so get familiar with the cosine of x graph. Now, what happens here is that it's cos of x plus 1. So cos of x plus 1. That tells us that there's a vertical shift of 1. So everything is moved up 1 unit. So everything is moved up 1 unit. So I'm just going to use a different colored pen. So this point here is now moved up to another 1 unit. So now we're up 2. This is at 0 right now. So we're going to move up 1. So now it's 1. This is at -1, move up 1, 0, move up 1, so that's 1, and then 1 moved up 1 is now 2. So the graph, the graph kind of goes like this now. Like that. Okay, so that's that. Now I did mention earlier at the beginning is y equals to cos of x plus 1. The d value tells us where the middle line is, the median line. So if we want, the median line used to be here. Now the median line is now up here. So everything, okay. This is not an asymptote. This is a median line. I can go a median line there. I'll just make it solid so people don't think it's asymptote. Okay, so the median line also moved up along with the graph. Okay, so that's what this graph looks like, the green one. And then the blue one is our original cosine of x graph. Okay. Now, another possibility, and maybe some of you have tried it in a slightly different way because we've done transformations before. So what if we do, this is one strategy. What if we do a mapping method? So using mapping method. And we could surely do that using a mapping method. So we know that our points, okay, our 5 key points are 0, 1, pi halves 0, pi -1. Okay, so doing the 5 key points. Now, with our mapping method, we said that x and y, after its transformation, it would become 1 over b times x plus h, comma, a times y plus k. Now the h is now changed to c. So we can, if we want, we can change that to c value. That's our phase shift. And instead of a k, that's a, we call that d. It doesn't really matter. Um, it's just the letters. Okay, so in this particular case, the only thing that changed is the d value, which is 1. Everything stays the same, so it's going to be x and then y plus 1. So that's the only thing that's changed. So what's the new transformation points? 0, 2, pi halves 1, pi 0, 3 pi halves 1, and then 2 pi 2. Let's see. And then if you look at this part in here, 0, 2. Okay, so I'm just going to zoom it out a bit so you can see it together. So the first point is 0, 2. 0, 2. That's that one right there. The next one is pi halves 1. Pi halves is here, 1. Pi 0, so pi 0 right there. 3 pi halves 1, so that's that point right there. And then 2 pi is 2. So we could use either method. We can use just graphing the normal cosine function and then translating 1 unit up. Or we can use a transformation method, and that's a possibility too. Okay, so that's that. This is for question number 7A. Some of these stuff here we will talk about today, so I won't spend so much time on it. Now what I'm going to do is I'm going to do y equals the sine of 2x. Okay, so the only thing that's changed in here is the b value. So the b is equals to 2. So therefore, um, everything is compressed by a factor of, horizontally compressed by a factor of 1/2. So that also tells us that the period is equals to 2 pi over 2, which is pi. So what does that mean? That for one cycle, one complete revolution, it would take pi radians. Okay, so what does that mean? The whole complete cycle will be pi radians. Now, here's what we're going to do. This is one possibility that we could do, and certainly we'll talk more about it in our lesson for today. Sine of 2x. Okay, well, what does the sine of 2x look like? First of all, what we're going to do is we're going to start with sine of x. So start with y equals to sine of x. Well, what's the sine of x looks like? So these are your angles. 0, pi halves, pi, 3 pi halves, and then 2 pi. So sine are the y values of the coordinate in the unit circle. So, so our xy, we're going to go the angles first. 0, pi halves, pi, 3 pi halves, and then back to 2 pi. So at pi halves, the y value there is oh, sorry, over here, the y value at 0 radian is 0. The y value of pi halves, y coordinate, in a unit circle is 1. Over here, at pi, the y value is 0. At 3 pi halves, the y value is negative 1. At 2 pi, the y value is 0. So the basics, so this is where those values came from. And then now the graph. So 0 to 2 pi. Okay, so remember the basic. Starts at 0, it ends at 0, so that's that one. Okay. Start, and then it ends at that point. That's one complete cycle. And then within that middle, that pi, that is the 0. Okay, this is a pi. Between 0 and pi, that would be our pi halves. It's going to be at 1. And between pi and 2 pi, so that becomes 3 pi halves, that becomes a negative 1. Okay, so the graph, it had, remember, this is a wave, a sine wave, goes up and then down and then negative and then up. Okay, so sine graph starts at 0, 0, up, middle, down, middle. That's a basic. Now, in this particular case, because the b is 2, it means that this got compressed. Okay, this got compressed by a factor of 2. So can you imagine this getting compressed here? So the period, that's why here the period is pi. The period is pi. So this is going to be staying here. This 2 pi got compressed to a half, which is at pi. Right there. This pi compressed to another half, which is 2 pi, or pi over half right there. This pi halves got compressed to a pi over 4. And then this 3 pi halves compressed by a factor of 1/2. So now that becomes a 3 pi by 4. So the graph now looks like this. Okay, so it got compressed. So now it's a half wide. And then if you want to do another one, we could, to do a complete thing. So this will repeat itself here. Okay, and then this one will complete there. And then this one right there. And this one right there. Okay, so now in the span of 2 pi, you can actually fit 2 waves. That's one way of looking at it. Okay, so another way of looking at it in a mapping situation. So if we are using mapping, this is what we're going to do. Okay, we said the b is now 2. Okay, so the factor is 1 over b. So it used to be like this. xy. Now because b is 2, it's going to be, this is the mapping, x, comma, a times y plus d. Okay, so the only thing that's changed here is the b value. So it's going to be x over b x over b. I'm just going to put 2 because the b is 2. There's no horizontal shifting. There's no phase shift, so 0. A times y. A value is 1, so it's just going to be 1y plus d. So there's no horizontal, no vertical translation, so that's going to be 0. So it used to be, this is what it used to be, 0, 0, pi halves 1, pi 0, 3 pi halves negative 1, 2 pi 0. Now, everything is divided by 2 for x. So if I divide the x by 2, it'd still be 0, so 0, 0. If I divided this by 2, so pi over 2 divided by 2, that's the same thing as pi over 4, 1. If I divide this by 2, it's going to be pi by 2, 0. If I divide this by 2, that's going to be 3 pi by 4, negative 1. And if I divide this by 2, it's going to be pi 0, which all of these points will be these 5 points here. And then just continue on. Okay, so there you go. I did question number 7A and 7B. You can now try question C and then question D if you haven't done it. I will post all of these online, so if you didn't catch everything, it will be there. Okay, I think that's the only ones that I'm going to go over with. If there's something in here that you want me to go over, I will go over it with you. Just let me know which ones to go over. And we'll go on from there. Okay, so this is the second thing that I would like to accomplish today. So the very first thing is just to kind of go over some of the practice questions that were assigned yesterday. Now we're going to do the lesson number 3. So let's just read on. It says here, recall A, the parameter A represents the vertical stretch or compression. And because it's vertical stretch and compression, it will affect our amplitude. Amplitude, we talked about the amplitude is the distance from middle line to the maximum or middle line to the minimum. Okay, so that's what that is. So if it's stretched, the amplitude gets bigger, and if it's compressed, the amplitude gets smaller. If A is negative, the graph is also reflected over the x-axis. So if A is negative, there is a vertical reflection. Okay, so vertical reflection over the x-axis. The B represents the horizontal stretch or compression, and this, by compressing it horizontally or stretching it horizontally, it will affect the period. If B is negative, the graph is also reflected over the y-axis. So this is a horizontal reflection. The H, okay, H or C, okay, because in our previous lesson we call it C, represents a horizontal shift. This actually shifts the starting point of our graph. Okay, and then that's a quotation. We'll talk about that in a second. And then K is a vertical shift. So this is also, I'll just put C here, or C, and then or D. D represents a vertical shift, which affects the median. Okay, we'll talk about that as well. So let's take a look at example number 1. Example number 1. Y is equals to negative 3 sine 2. I'm going to write it in a complete version of the parameters A, B, and C. So the A is negative 3. sine, that's our function. 2 is our b. And then x, I'm just going to go x minus c minus 0, okay, because there's nothing there, plus the d is 0. Okay, so this is a complete, um, everything is filled out. You got the a values, -3, the b is 2, c is 0, and then the d is 0. So that's going to tell us that there's a vertical stretching by a factor of 3. So if we vertically stretch our wave will get higher. Okay, and then -3 just tells us it's reflected into the x-axis. And then the 2, that's our period. No shifting of the starting point, and 0 is our median. So how we do this is this. So our amplitude is the absolute value of the a value, which is absolute value of a -3. Amplitude is equals to 3. Okay. Our period, okay, complete cycle, complete wave, how long will it take? It's going to be 2 pi over b. In this case, it's going to be 2 pi over 2, which is pi. Okay. Starting point. So starting point, okay, because we're talking about the sine, so the starting point, okay, so I'm just going to start with this one here. In the sine function, it starts at 0, 0. And then we go like that. Okay, so this is our starting point at 0, 0. There is no shifting, so that means our starting point will still stay at 0, 0. Okay, x equals to 0. And then when we see here, d is equals to 0. D is equals to 0. I'll just put c is equals to 0, so I got that. D is equals to 0, that means the median line is at y equals to 0. Okay, so x equals to 0, y equals to 0. Okay, what I could do, and this is what I've done before, is to box out where my graph is going to be. Okay, so I usually start at 0, the d. So the d tells us where the middle line is. Here's my middle line. Here's my middle line. Middle line. Okay. Now, because my middle line is here, and then the next thing that I do is, okay, amplitude. Amplitude is the how far from middle line to the maximum, and middle line to the minimum. So amplitude is 3. So amplitude is from here 3 units. So 1, 2, 3. And then because the amplitude is 3, amplitude is also from middle line to the minimum. Okay, so what we're trying to do is to kind of figure out how far up do we need to go, how far down do we need to go. So here, this is our maximum is at 3, and minimum is at -3. And then if we go here, the amplitude is 3 units. And then here is also 3 units. Okay, so what else do we need to do? The next thing that we do is phase shifting. Right as the starting point of the normal, because this is a sine function. Normally it starts at 0, 0, but then there is no phase shift. That means it doesn't shift left or right. It still stays at 0, 0. And then what happened is the period. Okay, well, we know that the period is pi. Complete cycle is, it stops here. Okay, so what I could do is one cycle. Okay, one complete cycle will be there. Okay, so what does that mean? My wave will start at 0, 0. It will go up maximum 3. It will go down minimum 3. And then it will do a complete cycle to pi. Okay, let's put it together. What are the 5 key points? So this is the first point ends there. Half of that, middle, that's where this point right here is. Okay, so I'm gonna do the 5 key points there. Half of that will be maximum. In between the point, these 2 points would be our minimum. Okay, so now we have these 5 points that we could do. Okay. Oh, one more thing that I have to do is this is what it would look like without, this is what it would look like without the reflection into the x-axis. So because there's a reflection into the x-axis, reflection into the x-axis. Now this one will be down here, and then this one will be up there. Okay, so let's just graph that. Now make it a solid graph. There you go. So our graph is like that. Okay, so that's just one complete picture. Okay. Well, because this is a sinusoidal function, it's a periodic function, it means that it keeps repeating over and over again. I can do it over and over again. So another block of pi right here. So I can repeat it over again. So this one would be that one. And then this one would be right here. So, or I can go this way and there. So those are my 3 points right there. And then this one is right here. And then this one is right there. So I can repeat it over again. And there we go. Make sure it's a smooth curve. This is one of the strategy that you can use. Certainly, we can also use mapping. We could also use mapping And how do we use the mapping if this is the case? How do we use the mapping? Okay, so normally these are the key points, right? Normally the key points for sine functions are 0, 0, pi halves 1, pi 0, 3 pi halves negative 1, and then 2 pi is 0. So these are the 5 key points. Okay. What I'm trying to do here is that I'm giving us another strategy in how to do this one here. The thing that I did here is one strategy, but if you are comfortable, if you prefer a different strategy, here's the other strategy, which is the mapping. So what's happening in here is that the amplitude is 3. So A is equals to negative 3. B is equals to 2. C is equals to 0. D is equals to 0. So if we do the mapping, it would be 1 over B times X plus C, comma, A times Y plus the D. So in this case, it's going to be the B is 2. So I'll write that over here. 1 half X plus 0. A is negative 3 times Y plus 0. Okay, so let's try to do the mapping in here. So that's going to be 1 half X, okay, 0, 0, or comma, negative 3 times Y. Let's see here. If X is 0, so 1 half times 0 is 0. 1 half times pi halves is going to be pi over 4. 1 half times pi is pi halves. 3 pi halves times 1 half, that's going to be 3 pi over 4. And then 1 half times 2 pi, that's going to be pi. Okay, so these are the x values that we have. What about the y's? The y's, I'm going to multiply by the a value, which is negative 3. So negative 3 times 0 is 0. Negative 3 times 1 is negative 3. Negative 3 times 0 is 0. Negative 3 times negative 1 is positive 3. And then 0 times negative 3 times 0 is 0. So if you go here, I was going to bring it down a bit. We're going to get 0, 0. So that's that one. Pi over 4. So pi over 4, if this is pi, 4 equal parts, this pi over 4 is negative 3. So negative 3. Pi over 2 is 0. So it's this one. 3 pi over 4 is going to be at 3. And then pi is 0. Pi is 0. And then you just keep going and do it. Okay, so 2 ways you could do this. You can chunk it, okay, just looking at all of these information. Also, we can say, hey, I could also use my mapping skills that we've done before. Okay, so 2 possible ways of doing this. Okay, now let's try B. What does the B value here? Or what is the B? I'm going to write down all the parameters A, B, C, and D so they're all clear in here. So I can say, hey, this is going to be Y is equals to, the A here is not given, but it's 1. Okay, zoom in a bit. 1 is our A. Cos B is 1/2. 1/2. Now, there is no brackets around here, so that tells me that x minus 0. So that means 0 is the phase shift or horizontal shift. And then the minus 4 is our vertical shifting. So it means bringing it down 4. Okay, so I'm going to do it in the strategy that I've shown you at the beginning. So they're telling us that the A value is 1. So A is 1, so that means the amplitude is equals to 1. Now, the B value is equals to 1/2. So that means the period is going to be 2 pi divided by 1/2. So if I take 2 pi divided by 1/2, that's going to give us 4 pi. 4 pi. C is our phase shift. That means 0. Now, you got to take a look at this one. We're talking about cosine function. What does a cosine function look like? Cosine function looks like this. Maximum, another maximum. Okay, so the starting point is supposed to be at 0, 1. So starting at 0, 1 right there. So x at 0. So there's no horizontal shift. And then the d is equals to -4. So that means that everything was brought down. The median line is at y equals to -4. Okay, so we've just by looking at this function, we can figure out what's the amplitude. The amplitude is the A value. We can figure out the period, how long it takes to make one complete cycle. There is no horizontal shift or phase shift, so the starting point for cosine will stay at that same place. So x equals to 0. Okay, x equals to 0. And then, right there, and then its vertical shift is -4. So it will bring down everything by -4. Oops. So what did we do? I start off with the, the vertical shift, -4. Oh no. Okay. I don't think they gave us the right picture in here. Okay. I don't think we have the right graph in here. So what we're going to do, because we have to go down 4. Okay. So we're going to simply change some stuff in here. We're going to go down 4. Let's fix something in here, because I don't think we're going to get everything fitting in that situation. So let's fix this. We're going to call this, change our scaling in here. Okay, so this is going to be -1, -2, -3, -4. So this is going to be -1, -2, -3, -4. Okay, -5, -6. Okay, so that one. So let's start with a -4. That's a median line at -4. Okay. Okay, this is not an asymptote, and I want to make sure that I know how far down I went. Okay. -4. Now, the next thing that I'm going to do is the amplitude. Amplitude is the distance from median line to the maximum or median line to the minimum. So if the amplitude is 1, so if this is -4, I'm going to go up 1 right there. That's median or middle line. Because our amplitude is 1, so I'm going to go up 1 unit, and that's my maximum. So that's a great thing. We could actually figure out our maximum. And then because here's our median and amplitude is 1, so that means we're also going to go down 1. Okay, so amplitude is the distance from median to max or median to minimum. Okay, so we know from this information is that we're going to fluctuate between -5 to -3, go up and down. We're not going to go past that one. It's going to go in between -5 and -3. What's the next thing that we're going to do? So we did the D, we did the amplitude. The next thing is we're going to do the B value, which is the period. So the period, it means this the whole cycle is going to be completed in 4 pi. Okay, so one complete cycle is 4 pi. Okay, so where is my 4 pi? My 4 pi is from here, from 0 to 4 pi. Okay, there. Okay. Now, because our graph, okay, when we look at this one here, it starts to, in terms of cosine, we start with the maximum and then ends with a maximum. So within this rectangle over here, that's where our graph is going to be. We're going to have a maximum, start with a maximum, and with a maximum. Okay? And then between maximum and minimum is our, between maximum and then the next maximum is our minimum. So halfway there is going to be, this is half, it's going to be at the minimum. And then half of that is going to be in the middle. Half of these two is going to be the middle. So our graph will go like this. Okay, so we've completed one graph of a cosine, one full wave. Now we're going to do the next one. Okay, so another 4 pi. Another 4 pi, that's going to take us to 8 pi. Right there. So repeat it again. So this maximum to the other end is a maximum. Between there is a minimum. And between these 2 points is going to be the median. Between these 2 points, there's going to be another thing in the median. Okay, so this. There. So that's one possibility of our graphing. Okay, so I'm going to try the strategy of mapping. So what if we do mapping? Okay, so some people might like the strategy, and that's perfectly fine. Some people would prefer the mapping. That's perfectly fine as well. So our mapping would be x, y, and if it maps, it's going to be 1 over b. So b is a half. So if we go 1 divided by a half, that's going to give me, I'll just do that, x plus C, 0. A is 1 times Y plus D, so plus -4. Okay, so I can simplify this a bit because 1 divided by half, that looks so weird. So we can just put it 2x, 2 times x. So if we do the mapping, here's a mapping. Okay. With mapping, I have to remember the 5 key points. 5 key points, 0, pi halves, pi, 3 pi halves, 2 pi. And that's going to be 1, 0, -1, 0, and 1. Okay. And then I'm going to apply this one here. So it's 1 divided by 1/2. That's going to be 2x. And then y minus 4. Okay. So 2 times x, so 2 times 0 is 0. 2 times x is pi halves, so 2 times pi halves, which is just pi. 2 times pi is just 2 pi. 2 times 3 halves is 3 pi. 2 times 2 pi would be 4 pi. Okay, well, that one's not too bad. And then y minus 4. So y minus 4, if 1 minus 4 is -3. 0 minus 4 is -4. -1 minus 4 is -5. 0 minus 4 is -4. And then 1 minus 4 is -3. And then if you take a look at these points, 0, -3 is this point right there. Pi, -4. Where's pi? Right there. So this is pi, -4 is right there. 2 pi, -5 is here. 3 pi, -4 is there. 4 pi, -3 is there. Okay? Two different strategies. We get the same graph. Okay, now let's see what we could do with letter C. Well, it's going to take a little bit of a time, but let's see if we can finish this part here. Okay, so y is equals to sine of x minus pi over 3 plus 2. Okay, what does that mean? Well, everything is almost filled out. The only thing that's missing here written down is 1 for A. So I'll just put that there. And then 1 for B right there. So what does that mean? Get rid of this part there. What does that mean? So amplitude is equals to 1. Period is going to be 2 pi over b, 2 pi over b, which is over 1, which is 2 pi. That means we're going to have one complete wave in 2 pi. And then our phase shift is pi over 3. That means our phase shift is pi over 3. That means C value is pi over 3. We're going to start over there, pi over 3. Okay, shifting to the right. And then that means a vertical shift. That means our median line would be at y equals to positive 2. Okay, so all of these stuff, we'll try that first. We'll try the median line at 2. Median line is at 2. So I'm just going to do my median line at 2. Right there. My amplitude is 1. So this is 2. My amplitude is 1. So I need to go up to 3. need to do one up, 1 unit up, and then 1 unit down. So that will take us to the minimum. Okay. So now we have kind of like a boundary of how far up we need to go, and then a boundary on how far we need to go. So this is a median. This is the maximum. And then this is the minimum. Okay. So that talks about median line and amplitude. Now, I think what I'm going to do is I'm going to start with the phase shift over here. Our phase shift, that means our sine function, remember our sine function is going to be from median, maximum, median, minimum, median. These are our, this is what the basic sine function looks like. Okay, I gotta remember that all the time. But this one here, we gotta start at pi over 3. So instead of starting at 0, 0, we're gonna move pi over 3 this way to the right. Well, where's pi over 3? Okay, so from here to here is pi. So pi over 3 is over there. So this is pi over 3. So we've shifted our starting point at pi over 3. Like that. Okay, so now this is our starting point. Now, where would be our end point when we need to go to 2 pi? So from here to here, from 0 to 2 pi, that's 2 pi. But because we are starting pi over 3 this way, then we have to move the end point also by pi over 3. Okay, so we've moved the pi over 3 this way, and then pi over 3 this way. Okay, so let me repeat that again. We know our period is from 0. We know our period is 2 pi, so that means from 0 to 2 pi, that's our complete cycle. But because we have our phase shift of pi over 3, the starting point, will be shifted pi over 3, and then the end point at 2 pi would also move pi over 3. So everything is shifted. Okay, so what does that look like? Okay, over here, the sine function starts at the median line, and ends at the median line. Okay, if we look over here, it starts in the median line, ends on the median line, and then in the middle between those two, that's also in the median line, and in between these two is going to be the maximum. So what's the in between these two? We got 3 units here, so it's 1.5 right there. And then in the middle of these 2 points is where going to be our minimum. Okay, so our graph would look like this. Okay, median to max to median to minimum to median. So that's one complete cycle. Like that. Okay, so now we keep going. So another 2 pi. So how many is that? 1, 2, 3, 4, 5, 6. So that's going to be every part is at pi thirds. So 1, 2, 3, 4, 5, 6. So over here. So repeat it all over again. So median to median. It starts in the median, ends in the median. In the middle is a median. Between the first and the middle here is maximum. Between these 2 points, that's where the minimum is going to be. So our graph would look like this. Mhm. So now, as you can see here, we've passed the 4 pi. So over here, this is just going to be like that. Okay, so just kind of finish it off right there. Okay, so certainly we could do a mapping for this one. Just for the sake of time, I'm just gonna go to letter D and letter E. Okay, let's take a look at this one here. Oh, there's no lines, no indication whatsoever in here. So we're gonna start to do our own graphing in here. So what does that mean? So our A is 1/2. So that means our amplitude is 1/2. Our B value is 2. Our C value is pi over 6. And our D value is 3. So what does that mean? I mean, our amplitude is going to be 1/2. Okay. Then our period is going to be 2 pi over B, which is 2 pi over 2. Cancel, cancel. That means pi. That period means one whole wave should be in a span of pi. Phase shift, so shift pi over 6. And then to the right, and then vertical shift, the D value is equals to 3. It means the median is at 3. Median is equals to 3. Y equals to 3. Okay, we don't have any pictures in here. Now, here's the thing that we could do. To make it easier for us, is a trick. To make it easier for us, as you can see, we're shifting by pi by 6. So it would be nice to have our increments, our scale, along the x being pi by 6. Okay, so that's one thing that we could do. We can do pi by 6. We probably do it on here, on a graph paper. Okay, so y is equals to 1/2 cos 2 times x minus pi by 6 plus 3. Okay, so let's try that. You can do this on a graph paper. Okay, now my amplitude is really small, which is 1/2, and then I have to go up 3. That's our midline is going to be at 3. So I can go 1, every second one is 1, 2, 3, 4. Okay, so I don't have to have my graph really tiny. So I'm starting off with the median at 3. So I know median is 3. And then my amplitude is 1/2. So that means I need to go up 1/2. And I need to go down 1/2. Okay, so that's where my graph is going to be. From 3 is our median line. I need to go up a half, so that's going to take me to 3.5, and then go down a half, that's going to give me a 2.5. Now along the x-axis, I haven't done any scaling yet. I know that I have to shift by pi over 6, so it will make more sense if I do my graph every pi over 6. The scaling is pi by 6. So, okay, so how do we do that? Pi by 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. So this is going to be my pi. Okay, so this is going to, every one would be pi by 6. Pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, 5 pi by 6, and then 6 pi by 6 will give us just pi. So we're going to need 6 ticks for every pi. Okay, that's going to be 2 pi. Okay. So, okay. So what does that look like? Let's see. We need, so we've done our median line at 3. We've dealt with our amplitude of a half. So median, max, and then minimum down here. Okay, so what do we have to do? Our period, we said our period is every pi. Okay, every pi. And then we're shifting pi by 6. So this up to here, from 0 to pi, that's going to be one whole cycle, one whole wave. But this is if this is the starting point, but our starting point is pi by 6. So moving it pi by 6 this way, so that means I have to also move, if I move the starting line pi by 6, then I have to move back the starting line pi by 6 as well. Okay, so I don't know if you can see that, but I'm trying to kind of form a space over here. That's where my one wave is going to be. Okay. Now, what does a cosine graph look like again? Cosine graph looks like starting with the maximum and ends with the maximum. Okay, so this is what the cosine graph looks like. Remember that one. Starts with a maximum, ends with a maximum, and then minimum side here, median, median. So where's my maximum here? My maximum is up here at 3.5, and then I gotta end at the maximum. Okay. Somewhere in the middle, well, in the middle of that, that's where the minimum is gonna be. Minimum right there. If you look at this one, minimum is in between the starting and the end. And then halfway of that, well, where's the half of that? Half of that would be here. And half of these would be here. So our graph would go like this. And then up. Okay, so that's one whole graph, one whole wave. Now we got to do it another one this way. So another pi radian. So remember, every pi would be 6 ticks. So 1, 2, 3, 4, 5, 6. So right there. Okay, so cosine starts with a max, ends with a max, and then below here, minimum in between, and in between, again, between these two is a median, between these two is another median. There you go. And then now, when you see here, this part right there is basically going to be over here. So if you want to just complete the whole thing. Okay. Looking at that one, that's really, 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 really nice. I like that. Okay, this is a long lesson. Um, Thank you for your patience for watching this, and then we're just going to finish up the last one. Okay, letter E. Letter E says y is equal to 2 sine 1/2 x plus pi plus 1. Oh, this is really, really nice because it has all of the parameters. A is 2, that means our amplitude is 2. B is 1/2, so that's going to affect our period. We're going to have a horizontal shifting, a phase shifting to the left pi radians. And then we have plus 1, a vertical shift. So I'm going to do that all in here. So our A, our A is 2, so that means our amplitude. Our B is equals to 1/2, so that means our period is equals to 2 pi over 1/2. And then 2 pi over 1/2 is just 4 pi. So that tells us, oops, you can't see that. So that tells us that one wave is going to be in a span of 4 pi. Phase shift at negative pi, right? Because it's minus negative pi. So that means shifting it to the left pi radians. And then a vertical shift of 1. So that means the median is equals to positive 1. So y is equals to 1. Let's try to do that in here. Now, I could do it on here, but I think it's nice when we do it on a graph paper. Okay, so let's do it on a graph paper. Okay, let me have my thing in front of me. In this particular case, I have to move up 1 right there. That's my line right there, our median line. Amplitude is 2, so that's from median. I gotta go up to 1, 2, and then I gotta go down to 1, 1, 2, right there. So I'm just trying to plan my graph is gonna be. Okay, let's do that. And I'm shifting to the left, so I have to make a little bit of room shifting to the left. Oops. Okay. Okay, so my median starts at 1. My median starts at 1 right there. And my amplitude is 2. So median is 1. That's where my median line is going to be. My amplitude is 2, so I need to go up 2 units. So that brings me to 3. And then if I can go up 3 and then down 3 to take me down to the minimum. I mean down 2 to take me down to the minimum. My minimum is negative 1. So median is at 1 because our amplitude is 2. So that means the maximum is 3. And then minimum is at negative 1. So our graph will fluctuate between negative 1 to positive 3 and so on. Okay, what else do we know? So we did this and we did that one. The next thing that we're gonna do is I can see that this is pi. Okay, so it would be weird if we go pi each time, each unit or scale. That's going to be too squished. So I know that the phase shift is pi. Then I can just go pi halves. Ooh, my period is 4 pi. Okay, yeah, I guess I'll just do pi. That's going to be, everyone is pi. So this is going to be pi, 2 pi, 3 pi, 4 pi. Okay, so that's going to be 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. Okay. So this one tells me that I have to start, okay, my sine function, the period is supposed to be 4 pi. So period is 4 pi. But everything is shifted to the left pi units. So that means I'm going to go back pi radian here. So if this is my 4 pi, I'm going to also shift back the end pi. Okay, so this is where my graph is going to be, this portion here. Okay, so what does the sine graph look like? The sine graph looks like is median, max, median, min, median. So the starting point starts on the median. So I'm going to start here, median, and end. In between these 2 points is a minimum. So here, this is up, down, down, up. That's one complete cycle. Okay. And then repeat it again. So that's another 4 pi. So I can go 1, 2, 3, 4. That's going to be another 4 pi right there. Repeat it again. Median, ends in the median, middle, maximum, and then this is the minimum. Okay, so there you go. There we go. So we've completed a cycle. If you want to keep going, okay, so this part here will just go continue on to that part if you want to continue on. Okay, so there you have it. And certainly we can use a mapping for this one. There's a lot of things that we need to plan out to graph this. So a lot of information. Wow, we went over time here, and I just wanted to finish this. It's because it's going to be the weekend anyway. There's some assignment questions for us to work on. Okay, so these are the assignment questions for you to try. Please try them. Please stay on top of the work because we're gonna be done in just a few weeks. So yeah, make sure you work on these questions, and if there's anything here that you want me to go over, a specific question that you would like me to do or to show you, please let me know. Send me a message on my email. and then I'll go over it with you. Okay. Well, thank you so much for watching, and I hope that this goes really, really well for you. Um, and yeah, you can keep in touch and let me know if what works for you. If this one is a thing for you that you wanted to do, go ahead and try that. And if you like the mapping, that's another strategy that you could do. And certainly something that, yeah, either or is perfectly fine. Okay. Thank you so much. And goodbye for now. I'll talk to you soon. Okay. Bye.